Guys, cues that may give us issues that we will conquer. Hashtag not a lesson. So you're gonna need a calculator. So let me get the calculator warmed up while I get this going. Okay, so here it goes. The key here is just storing values in the calculator, and we'll store values in the calculator. Do you have a calculator, Ms. Johnson? Grab that one over there. I am missing several calculators, guys. As you can see, I have calculators out there because we're inventorying them. If you have any calculators at home that belong to me, please bring them. Do you know of people that have my calculators? Tell them to bring them. Okay. The volume of the sphere is increasing at a constant rate of 5409 cubic meters per second. Okay, so that's the volume, and it's increasing at a constant rate. So let this help you out. This is meters per second. So this is dV dt. So dV dt is equal to 5409 cubic meters per second. See? Difference in volume divided by difference in time. So there it is. At the instant when the volume of the sphere is 3276 cubic meters, so volume equals 3276 cubic meters, so cubic meters. What is the rate of change of the surface area of the sphere? So they want ds dt. The dt equals question mark. That's what they want. What is the rate of change of the surface area of the sphere? The volume of the sphere can be found with the equation. So they give us this. They don't have to, guys. They won't always. They don't have to. If you're wondering about the AP exam, will they give you formulas? If it's something like a sphere, probably. If it's something like a rectangular prism, probably not. Everyone, we know rectangular prism. What's up? You will not get a formula chart, no. But we're going to be doing these so common that you will know. Maybe I'll embed it in the problem if we really do need it. All right, so you see how they want the dsdt? They don't have to. They're being nice. They give us the surface area volume. So here's what I would have done. I think if I were a kid, I'd probably be like s equals 4 pi r squared. And I'd be like, well, that's what I want. I want dsdt. So I'm going to take a derivative of ds dt equals 4 times 2 is 8. 8 pi r dr dt. So catch up to here. And then you ask yourself this: do I have what I need to find ds dt? Do I have r? Notice I don't say r equals anything. I don't have r, at least not directly, but we can get it. And you don't have dr dt, at least not directly, but we can get it. Cool? How are we going to get it? Well, notice, let's do the first one first. How are we going to get r? Notice I have volume. So I can go, and I'm going to write it in blue. I can go 3276 equals 4/3 pi r cubed. Are we still okay? All right, I'm going to get r cubed by itself. So what am I going to do? Divide by 4/3 pi, or I guess you can say multiply by 3/4 and then divide by pi, but it doesn't matter, guys. Divide by 4/3 pi. Whatever you do to one side, you do to the other. And then, so now I have r cubed equals that. How do I get r from r cubed? Cube root. You can either go like this, cube root, or you can raise it all to the 1/3 power, whatever you think is easier. So here it is. I'm going to take my calculator. So here's my calculator. Let me clear. Oh, look, this is from another one. All right, here we go. I'm going to take my calculator. I'm going to go math number 4. And then I'm going to push fraction. Make sure it looks exactly like that. And I'm going to type in 3276. 3276 divided by, and I want it to look exactly like that. So I'm going to put another little fraction there. 4/3, and then put the pi next to it. There's no way it's going to be in the numerator. I mean, you can put 3276 times 3 divided by 4 pi. So they're just separate. The pi is going to be in the denominator.
Yeah.
Yeah.
No, what I meant is like, yeah.
4 pi over 3.
No. You can do 3 times 3276 over 4 pi. But the pi stays there.
Like 4 pi over 3.
Yeah.
Oh, yes.
Okay.
Yes. So like this guy.
Yeah.
Yeah, you can do that. As long as it's together with the 4, right? All right, so there it is. You see this number, guys? Do not round it. I like to go down the alphabet. Some of you, I've seen some of kids like to, well, this is R. I'm going to call it R. That's fine if you want to do that. I like to go down the alphabet. Store, alpha, A. So now my R is on A, and I like to show it like this. I go, at least how many digits after the decimal? At least 3. The more, the better, though. 9.213368. 9.21. I already forgot it. Short-term memory. 3368. And I'm going to put an arrow, and I'm going to say A. So now every time there's an arrow with an A, there it is. Guys, I want to make sure that you guys are aware, in case you guys are freaking out during the test, it doesn't have to look like this. You could have done this. Parenthesis, alpha y equals enter, 3276 over, and just like Morales said, she's going to go to pi with the 4 pi over 3. And then look, close it. What power do I raise it? 1/3. And look, you'll get the same answer. You'll get the same answer, guys. So in case you freak out the day of the exam, you have some type of anxiety, like, oh my God, I don't remember how do I get that third cubic root, like the math and the whatever. Just raise it to the 1/3. Just turn it into an exponent. Cool or not cool? All right, so there it is. I already have that saved in A. So I'm going to put a check mark now. So this one's clear. Now I need the DRDT. So I'm going to change my color. I'm going to go to purple. Well, I'm going to get the DRDT from this one. See? Child, what do you mean? Well, volume equals 4/3 pi r cubed. dVdt equals 4 pi r squared DRDT. Notice, I already have dVdt and I already have r. Do you guys notice that? So what was my dVdt? No, that was volume. 5409. 5409 equals 4 pi a squared dRdt. My a is this guy. And then I'm just going to divide. So dRdt is equal to 5409 divided by 4 pi a squared. And let's see what that is. I take my calculator. I'm going to go off a fraction. 5409 divided by, why is this thing on? Divided by what? 4 pi a squared. 4 pi. Be careful. Make sure it looks like this. You don't have to put parentheses on the A. You can if you want, though. The most common mistake that you guys make, don't write this down, just listen. Why is this not the same? Yeah, why is this not the same? The calculator is dumb. It's a machine. You guys have taken computer science before, right? The calculator thinks you're doing 5409 divided by 4. And whatever that is, multiplied by pi a squared. So if you're going to do it like this, use parentheses. So I recommend, so to never mess up, always just do the top one here. And you'll never mess up. Does that make sense? Okay. All right. So look, check it out. I'm going to push enter just so you can see it's wrong. See? Look at that. That's a huge number. Of course it's wrong. All right. This is my answer. This is what I want. This is what I'm going to store. I go down the alphabet, so I'm going to put it into B, 5.0707. So that's what I'm going to write. I'm going to put 5.0707, and I'll put an arrow, and I'll put B. All right, I got my answer now. Here we go. My answer, what is it? So I'm going to write dSdt equals 8 times pi times A times B. There it is, because I have it saved in A and B. See, here's A, and here's B. So I'm going to take my calculator. 8 pi alpha A, alpha B. You can put parentheses if you want, if this irks you. And there it is, 1174.163. 1174.163. And I need units, square meters per second. That's the rate of change of my area, or surface area. What's up, Kyle? Heck yeah, I can scroll up. Hello, miss. What do you think, Morales? What do you think, Zamora Johnson? You gotta store. You gotta store them. We're gonna be using the calculator a lot more now. All right, you guys ready? Or you can do Desmos as well. We'll show you guys when Desmos is appropriate. The area of a square is increasing at a rate of 153 square inches per minute. Okay, so that's DADT. 153 square inches per minute. At the time when the area of the square is 81 square inches, at the time when the area of a square is 81 square inches, what is the rate of change of the perimeter of the square? Okay, perimeter. Here's my square. Perimeter of a square. This is S, this is S, this is S, this is S. I know, I didn't draw it perfect. That's fine. And they should all be the same. That's an S, not a 5. Perimeter. 4S. So what do I want? I want the rate of change of the perimeter. Rate of change of the perimeter of the square. So that's dP dt equals 4 ds dt. All right. I do not have ds dt. How do I get it? Well, from the area. Area of a square is s squared. You actually need to find s, but since we already know that area is 81, since this equals 81, semicolon, s has to equal 9. Do we understand that, guys? All right, here we go. dA dt equals 2s ds dt. I know what dA dt is. It's 153. So put 153 right here equals 2 times 9 ds dt. Semicolon. ds dt must equal 153 divided by 18. That's what 2 times 9 is. That's 18. So I'll take my calculator. 153 divided by 18. And we get 8.5. It's a nice, pretty number. 8.5. All right, now that I know that that's ds dt, I'm going to plug in 8.5 right there. All right, so dP dt, I got more room down here. Let me write it down here. dP dt equals 4 times 8.5. 8, 16, 32, 334. 34. 34 inches per minute. How do we feel, guys? Was everything explained clearly? Yeah, I know it's towards the end of the day. Everyone's tired, but Ms. Kyle, was everything pretty straightforward? All right, guys, we're done. You have an hour and 10 minutes.